Before we go any further, however, we must acknowledge that the systems we are interested in are much more than an aggregation of hardware or software products, and must also be described in terms of all of the constituent elements, including the major hardware and software, of course, but also the organisations within which the system will be fielded, the personnel who will interact with it in many ways, the collective training systems required, as well as the facilities, the data, the support, including even supplies, required to keep the system in service, as well as the operating procedures and organisational policies. The system is fully defined by the combination of these resources operating in its operating environment in order to achieve its purpose, its mission. In that sense, then, we can define a system as delivering an operational capability. It's common, therefore, particularly in defence environments, to refer to the system at this level as a capability system. In the US Department of Defence, the acronym DOT-MLPF refers to the capability system elements of doctrine, organisation, training, materiel, leadership, personnel and facilities. In Australia, the capability system is considered to comprise fundamental inputs to capability, or FIC, command and management, organisation, collective training, major systems, personnel, facilities, supply and support. In the United Kingdom, the defence lines of development refer to doctrine and concepts, organisation, training, equipment, personnel, infrastructure, logistics and information. In Canada, the acronym PRICE refers to personnel, research and development, infrastructure, concepts and doctrine, information technology and equipment. And all of these acronyms refer to a system as a capability system. Now, having acknowledged, therefore, that a capability system has a number of elements, it must also be recognised that each of those elements will probably have a different acquisition cycle. For example, people will be acquired in a different manner to that in which the major system was developed. And each element of the capability may even be acquired by a different acquisition element of the organisation. Consequently, joining all these subsystems together into a system is actually a complicated effort. In the remainder of this course, for ease of description, we focus on the acquisition of just the major equipment element, often called the material system, to make it easier to understand the linear sequential process. We must always keep in mind, however, that this acquisition is being undertaken in parallel with the acquisitions of the other elements of capability, and that all of those elements must then be brought back together prior to introduction into service in order to field the full operational capability. So, for example, in an aircraft system, the resources for that capability system are many. They will include, but not necessarily be limited to, the people we need, so the personnel. We need aircrew to operate the system and ground crew to maintain and support the fleet. We need support. We need maintenance facilities and equipment for routine maintenance and repairs. Materials are required to operate the system, including the fuel, of course, and lubricants and other consumables such as tyres and spare parts. We need facilities for support and for operations. We need terminals and support facilities to maintain the aircraft. We need organisations and policies and procedures. ACME, the company that runs the aircraft, will need to conform to a significant number of regulations and will need appropriate organisational structures, policies and procedures to operate the aircraft effectively. We'll need collective training systems. The aircrew and the ground crew will require training throughout the system lifecycle. We'll need data. Data is required to maintain and operate the aircraft, and also to include maintenance information such as specifications and drawings, and operational information such as user manuals and instructions. But then finally, of course last but not least, we need the major equipment. We need the aircraft. The aircraft will need to be produced and then deployed to those operators who will use the aircraft in a number of different ways, and of course one of those users will be ACME. Of course, there is much more to major equipment than hardware. Software is also now a critical item within many systems. The aircraft will use hardware and software to control a range of functions from engine management through navigation and environmental control, communications and flight control systems. If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.